Good evening, everybody. Welcome to Propagation Space Month 2026, the world's biggest space science outreach initiatives. And it is my pleasure to introduce today's speaker, Dr. Gourav Banerjee, Postdoctoral Fellow at Indian Institute of Astrophysics and Associated at Vainu Bapu Observatory. We have had him before, and he is an awesome speaker. He has taught us a lot. I really enjoyed one of the last sessions that he did. I'm very interested in this. So I'll move on to further explaining about him. Dr. Banerjee specializes in the spectroscopy study of stars and holds a PhD and MPhil in astrophysics from Christ University, along with an MTech in astronomy and space engineering from Manipal University. He is a life member of International Astronomical Union, that is IOU, Astronomical Society of India, ASI, and Interplanetary Society, IPS, and has delivered over 500 astronomy talks across India. He is also author of two books, Becoming an Astronomer and Mars, the Celestial Showstopper. Today, he'll guide us through astronomy, past, present, and future prospects. Please join me in welcoming Dr. Gourav Banerjee. The stage is all yours now, sir. You can start with the session.
Yeah. Hi everyone. First of all, little bit sorry because I was having some other work. So, good evening everyone, and obviously it's a pleasure to be a part of this program. Thanks to Propagation Institute and the team for this wonderful initiative and doing a month-long space science and astronomy related outreach programs. Well, I will just switch off my video so that I am more audible. Today, let me share my screen. So just give me a second. Just tell me whether my screen is visible or not to all of you. Yeah. I hope my screen today is visible, right?
Yes, sir. It's visible.
So let us start today, and welcome first of all on behalf of IIA, Indian Institute of Astrophysics. And today, since we will be speaking about this broad topic that is past, present, and future of astronomy as a whole, let me concentrate as of today little bit focusing on what is the past, present, and future status of astronomy, and mainly focusing on Indian perspective, since I believe that most of the participants who will join today will be from India. And I know that there will be different, maximum of the participants might be students. So because talking about astronomy in a global perspective in one talk, it will be too large. It's beyond the scope of one talk. Maybe we can take it over in future in maybe a series of talks. So welcome all of you. Well, what is astronomy? How it started? When it started, we basically do not know. But it started something like this. It was random maybe. And even if we go to these ancient days, if you go back very early to these ancient days, we might see people suddenly, without any reason, looking up to the sky like these primitive people. Why people started looking up towards the sky? There is no particular answer for this. When they started looking up at the night sky or the day sky, also we don't have a proper answer. However, we human beings possess some very special characteristics which is not possessed by any other animals, any other living organisms. And one of that characteristic, which is important characteristic, is curiosity, natural curiosity. See, most probably because of this natural curiosity, human beings started looking up at the sky, most probably. And from very ancient days, maybe from the very first days when the species Homo sapiens, human beings, modern human beings, first appeared in our earth, maybe from very early those days itself, they started looking at the sky, and the sky was beautiful, the sky looked towards them, and they didn't know what these objects are. However, as we have intellectuals, we have scientists, we have very brilliant people in our modern world also, during those days also, there were intellectuals, although we do not know their names. So looking after the sky just for curiosity purpose gradually was becoming meaningful to some of those people. So if we just go outside our home, go to a jungle, go to a place where there is no light pollution, maybe for hundreds of kilometers in some very deep, remotest places of India or abroad, and look at the sky, you will see a sky full of stars like this. It's a place where I am staying during it. Now it is monsoon time, but during winter times when the sky is clear, we see a sky like this. It's a remote place. It's a jungle. Now, this same view might appear very meaningless to us, and that was the same case for the primitive people thousands of years ago. However, there were few people, as I was telling, there were some intellectuals little bit more wondering than others. They understood for years of observation and watching this night sky that this night sky can be of some help. How? If we go on looking at this night sky for years after years, days after days, so some primitive people, they identified, okay, the night sky somehow is looking like it is repeating back. So some of these dots, we mostly now know these are mostly stars here. In this picture, mostly are stars. So, but these stars, these dots are actually appearing back. So if it is appearing back, this can be of help to us. How? So what they did, they started joining some of these bright dots in the whole sky, and they started forming some imaginary patterns. In this place also, in this particular patch of sky also, we can do this. You can take any of the dots, make some known patterns, make some imaginary patterns according to your wish. So what primitive people looking at this same patch of sky, they also didn't stop. They also formed some patterns, the famous pattern of Saptarshi Mandal. This is the Saptarshi Mandal, that huge question mark in the sky. The famous pattern of Saptarshi Mandal came like that. And so this became the first indication that sky can help humanity. How? Because if we can divide the whole sky into such imaginary known patterns, and these known patterns will one day reappear, that is after the change of the season, or after the change of the year, or after the change of few months, then the sky will start acting like a calendar, like a tool for navigation, like a guidance tool. And see here, this is how we identify the sky. If we just see this constellation, the first two stars, Alpha and Beta, Morichi and Boshishto, if we join these, Puloha and Kritu, the first two stars, these two stars you join with an imaginary line, project these two lines. Merak and Dubhe is the English name of these two stars. Project these two lines around 5 times, you will hit a comparatively brighter star. And that bright star is the famous pole star or Polaris, the star which will always remain fixed, at least in one lifetime or one human being's average lifetime. This star remains fixed in the North Pole. That means by identifying one particular pattern of Saptarshi Mandal, we can identify the north, the true north in the sky, and that will help us to identify the whole sky, the directions. Likewise, as time progressed, this ultimately also progressed. This knowledge of identifying the stars and constellations, these imaginary patterns are actually known as constellations in the sky. Definitely the most famous constellation of the sky is the Orion, the hunter. In Bengali, what we call as Kalpurush, or in Hindi also we call Kalpurush. So one imaginary hunter sitting in the sky trying to hunt a bull. In modern astronomy also we follow these patterns because this is the best way, very easy way by which we can divide the sky, and the sky becomes a map to us. The first map, the first calendar for humanity came from studying astronomy, from studying the stars, from studying the sky. However, this pattern should be named properly. So if I am telling this is a hunter in India, if somebody else is telling something else, then these are all imaginary patterns. So then it will be a confusion. So to avoid that confusion, we have a body, International Astronomical Union, the largest professional body of astronomy related rules and regulations in the world. It has its headquarters in France. So in 1928, International Astronomical Union told that, okay, we will adopt some particular figures, some particular names and patterns, and this is how we will divide the whole sky. And as of now, The whole sky is, that is why, divided into total 88 constellations. If I look into those, suppose this particular patch of sky, see how this sky is divided. This is the famous winter sky. The winter sky from around October onwards, which we see from our northern hemisphere. Any part of northern hemisphere, you will see this type of sky during the winter time. Where is the Orion? Where is the Hunter? This is the Hunter. If I put the figures here, this is how the figures will look like. So basically, this is how the whole sky is divided into 88 constellations. And from those early days, from those early non-writing days where there was no write-up, no documentation, from those days itself, astronomy started like this. It started because humanity needed something to survive. Humanity needed to know when to cultivate crops, how to cultivate crops, how to move from one place to another. Thousands of years ago, there was no compass, no calendar, nothing was there, no electronics, no technology, nothing. So how they will remain safe? Think about the earliest all major civilizations, maximum major civilizations took place or occurred near to a huge river. So these are all river-based civilizations. And we know, we go to Indus River, go to Nile River, there are huge floods which comes. So thousands of years ago, how will you predict floods? Today we can predict because we have weather forecasting, and that too came from studying astronomy. So in primitive days also, astronomy, or understanding the sky, understanding the basics of sky observation, helped humanity to identify seasons, to identify when we should cultivate what type of crop, to identify, okay, what type of festival will take place in which time of the year, which time of the, how time is passing. The clock, the navigation tool, the calendar, everything was sky. And this is how from the past astronomy started. The term astronomy came much later by the influence of the Greeks. And presently we are standing in a huge, excellent time of astronomy. If I come back from those days to ancient times when we had documentation, so people were understanding, people understood that just by looking at the night sky through naked eyes, you cannot measure. For measuring, for quantifying, for doing some science, you need some instruments, you need some tools, we need something. So those tools we have to produce. And as people came to the Bronze Age, Copper Age, gradually people understood, okay, we have to take astronomy seriously. So they started predicting seasons, they started doing astronomy in a more better way by producing some tools like this. These are all primitive tools. One of the earliest known astronomical tool of which humanity used is known as this, astrolabe, and till now we use this. The modern name of this astrolabe is sextant. So people or students, all of you who are studying in higher classes, definitely you have heard the name sextant. So it's like a compass. It acts like a compass, a type of compass. By using this sextant or astrolabe, we can identify the altitude or the latitude of a place. Any place you take this astrolabe or you take a sextant, by using this astrolabe, you can identify what is the latitude of your place. And if you know the latitude, you can also calculate longitude by mathematics. So this astrolabe became one of the first astronomical instruments which was discovered. Till now it is used. This particular astrolabe is around 500 years ago. This is a picture of an astrolabe which was used around 500 years ago. However, if we come gradually towards the modern age also, we will see this type of instruments made up of stones, made up of wood, huge, heavy instruments. They are till now used in some cases because these are easy. Some of these instruments are easy to use. Definitely all of you have heard this term known as sundial, Sujjagori. Sundial is an instrument by which we can tell the time using sun. This is a very simple demonstration of a sundial. You can see at what particular time the sundial is placed in a field. So by looking at the shadow projected through this erected spine, we can tell the time using sun. So this is during the morning it will work. That means the first clocks, the proper clocks for humanity also came from studying or understanding astronomy, how sun, how planets, how stars are passing, how they are moving in the sky. However, this sundial will work only in the day if the sun is there. Don't think, my friends, that okay, at night then how will I tell the time? That means at night we cannot tell the time. Yes, we can tell the time. I personally do not use a wristwatch. I personally do not need much to look into the mobile phone for what, telling my time, because if the sky is night sky, if the night sky is clear, then I know what is the time. So one way, there is another instrument which is a counterpart of this sundial, like a brother or a sister of the sundial, that is known as nocturnal. Nocturnal, in good terms, I tell is Ratri Ghodi. Ratri Ghodi. So a clock which helps us to tell the time at night if some particular stars are there in the night sky. Even this can be done using the help of that famous Saptarshi Mandal or question mark. It can be modified into your own way. So yes, if you have a nocturnal in your hand, an instrument known as nocturnal and sundial, then I don't need a watch. I don't require a watch, because an electronic watch can sometimes fail. But this is not electronics. This will never fail. And for our understanding, as I am trying to focus a little bit more on Indian perspective, you see, in India also, astronomy, the way we understand astronomy today, it is a modern concept. But practice of astronomy for understanding time, for calculating when to cultivate crops, for their need, for day-to-day need, for understanding what type of festival should take place in which particular time. For these practical purposes, astronomy was already there in India also. So even if you look into this particular picture, you will see, so there was a king, a Rajasthan king, Swai Jai Singh II, in 1730s, during this time of 1720s to 30s, he made some observatories in different parts, 5 observatories in different parts of northern India. One of the best such ancient astronomical observatory in the whole world is this Jantar Mantar in Jaipur, and it is still working. The largest working sundial in the whole world is this one, made by Swai Jai Singh. It is known as Shamrat Jantra. It still works, and you see, this is how the shadow of the sun is falling here, and it's so precise that it can give you time every 2 seconds. That is the precision. Every 2 seconds you will see the time, exact time. So I will suggest all of you, please, once, if you love astronomy, if you want to know astronomy more, if you want to get thrilled by astronomy, just visit this place once, Jantar Mantar of Jaipur. Apart from Jaipur, he made another Jantar Mantar observatory in Delhi also. That is also surviving up to a certain level. Some of those instruments are there, which is present in Jaipur also, but definitely visit the Jaipur Jantar Mantar once. Take a guide. There is Archaeological Survey of India guides are available, and visit this whole Jantar Mantar observatory. You will be amazed to see, when we didn't have modern technology, modern science, or modern electronic gadgets, how astronomy was done. How astronomy was done. It's a marvelous place. So this was the stage where India astronomy was present, but that astronomy was more into not just for curiosity purpose, not just to learn or understand, well, I want to do astronomy because I want to know how stars are dying, or why supernova blast is happening, how universe has started. Not this type of astronomy. This is a broad astronomy part. To understand the fundamental physics, to understand the fundamental questions regarding astronomy, regarding physics, regarding space science, and even humanity. So the astronomy which was practiced in ancient India till around 1800 and more than 1800, it was for purpose-built astronomy. It was mainly to understand, so that we can live a better life. That is why if we need some astronomy, that was purposefully practiced. And before 1730s, if we go back, we will see a long list of astronomers in ancient India. Definitely, one of the most famous, maybe the most famous, the most brilliant astronomer of ancient India was Aryabhatta, the picture whom if you are watching. But apart from Aryabhatta, you see in one slide, as much as possible I have given, there are Brahmagupta, Varahamihir, Lagad, Aryabhatta 2, Bhaskara 2, Lalla. There are more number of very good astronomers who came. And even during the time of 7th to 12th century, for around 400 years, in Kerala, one school of astronomy was there. How many people know that the world's longest running astronomy school was in India? It ran for more than 400 years with glory, and that was known as Kerala School of Astronomy. There, within 400 years, it has produced a number of top level astronomers. Definitely the best one, for whom I can respect the most, the best was Nilakanta Soumyaji. You can read about these people, just go to the internet, type up about their names, what is their contribution. However, I would definitely like to point out that the astronomy which we know now, the way we practice astronomy as a whole nowadays, that is different. And this is why Aryabhatta becomes very much different from ancient other astronomers of India. Because he was the first, apart from practicing astronomy for our lively needs, he was the first person who started looking into the sky and started asking questions, okay, why a solar eclipse is happening? Is Earth round? Is Earth revolving or rotating? Okay, what is the speed of rotation of Earth? What is a lunar eclipse? So these type of questions seldomly will be asked by astronomy people during those days in India. But this is why Aryabhatta is absolutely different from all of them in ancient India. You can read this. Aryabhatta was not only asking questions, he was the first person, he is the first person in the world who explained properly how a lunar eclipse and solar eclipse works. He is the first person who actually measured by simple mathematics. He measured what is the rotation speed of our Earth, and that is so perfect. With the modern technology, modern supercomputers, when people have measured that value, it is just 0.04 seconds error. So basically, how we know about these things that he did it, because he wrote a book, Aryabhatta, and in that book, all these things are there. So this book was written at some period between 480 to 580. So around 1500 years ago. So now if I come to modern India, now if I come to the modern days, astronomy is, now we are standing in a golden age of astronomy, we can say. But that was not the case during these days. Think about a world 1500 years ago, it is unthinkable. People had no idea where we are staying. People had no idea what is science, what is technology. Even we had the belief that our Earth is the supreme, we are at the center of everything, and sun and all other planets and all other things are revolving around us. This was the Earth, this was the situation 1500 years ago, even 500 years ago. But gradually, when science started, when astronomy started in a modern way, it changed. So not going to the details of this all long history, let me come to the modern days now. If I look into those ancient days, if I talk about the instruments of those ancient days, see, we have to understand just by naked eye or by those huge instruments which are fixed in the ground, or even huge instruments, wooden instruments, heavy metallic instruments or machinery instruments, we have a limit. By that, in those instruments, we can study the sky, but up to a certain limit. So humanity had to wait for the discovery, for the invention of maybe, possibly, one of the best instruments ever invented by humanity in the history of our whole lifetime. And that is the telescope. So with a telescope, we can see farther objects, fainter objects, brighter and bigger, and that actually revolutionized astronomy. So in 1609 onwards, when Galileo first pointed his telescope towards the sky, it changed everything. That is why 1609 is regarded as the birth of modern science, the birth of modern astronomy, the birth of modern thinking. But my friends, as a note, I would like to say one more word. or one more sentence, please remember that Galileo was not the inventor of the telescope. He was the first person who actually used a telescope to look into the sky. 1 year before him, according to history, according to documentation, we know that there was a spectacle maker, not a scientist. There was a spectacle maker, a Dutch spectacle maker. 1 year before Galileo, his name was Hans Lippershey. He was the person who received the patent for inventing a telescope. So, according to documentation and history, Hans Lippershey is the person who invented telescope. But 1609, within 1 year, this news came to Galileo. He also made his own telescope and he started looking at the sky. Okay, if I have an instrument which can show me farther objects in bigger way, fainter objects in brighter way, then what is the farthest objects we see? The sky objects, the objects in the sky. So let's see what is there in the sky. And that changed, that revolutionized science, that revolutionized human thinking, and definitely that gave birth to modern science and astronomy. So from there, those days of ancient days where we are only using naked eye observation, or we were using only huge machinery instruments made of rocks, made of stones and huge heavy metals, or even wood, this got transformed. And if I go through the history, how it got transformed within the 400 years of time after the discovery of telescope is extremely fascinating. I will suggest do read some books on history of astronomy. There are several books available in the market, in Amazon. Just search it out. And if you people want, then maybe in future I can put a list of some good books. You can read them and see how astronomy got transformed within these past 400 years. And what was the status of astronomy before the discovery of telescope for 1500, 2000 years. So now what we have, see the telescopes which we are showing you here, these pictures, these are basically wonderful telescopes, but these are small telescopes. These also have limitations. These are known as amateur telescopes. Why? Because with these small telescopes, these are handheld small telescopes. You can take it to anywhere in a car or in your backpack. Some telescopes you can again carry in your backpack. Also, we have binoculars. So with this type of instruments of this level, you cannot expect to see the night sky, or you cannot expect to understand the night sky the way we can understand now. Or Hubble telescope, the way Hubble Space Telescope or James Webb Space Telescope watches the night sky, that view we will not get from here. So astronomers like us or other astronomers, professional astronomers, which type of instruments or telescopes we use? We have to use some very big telescopes, professional telescopes, and these are some of those. So the first three you see, these are huge dome-like structures. These are known as astronomical observatories. So all these places, if you see carefully, you will see it will appear that all these places where astronomical observatories are present, they are in remote places, because light pollution should not be there, noise pollution should not be there, dust pollution should not be there, as much as minimum dust pollution should be there. So these conditions we can only get in a remote place, not in a city, not in a light polluted area. So in those type of remote places, you see huge domes with huge telescopes using sophisticated technology and electronics. With this type of telescopes, if you look at the sky, you can actually study the physics of the astronomical objects. Otherwise, with small telescopes, you can definitely get the beauty of the sky. Sky is beautiful, but to understand, okay, why the star Betelgeuse is looking red, to understand the physics behind it, the small telescopes will not help you. You have to become a professional astronomer and use this type of professional top class facilities. These are all in our Earth, in different places of Earth, but these are outside India. The last picture is an artistic impression of the largest telescope which is going to come, the largest optical telescope, which is known as the 30-meter telescope. So when it will come into shape, you see how big this telescope will be. There is a full-fledged truck standing in front of it. Now in India, we have this kind of telescopes? Obviously, yes. Obviously, yes. So one of the largest, one of the topmost institutes in whole of Asia for optical astronomy is the Indian Institute of Astrophysics, where I work. It itself has 4 particular observatories in different parts of India. And I am situated in this particular observatory. I do my research, I stay here, Kavalur Observatory. I will come to this. So this Kavalur Observatory is in Tamil Nadu, in a very dense forest of Tamil Nadu. And it is mainly dedicated for optical astronomy, studying galaxies, mainly stars, galaxies, some planetary objects like this. We also have a very old solar telescope or solar observatory at Kodaikanal. This is also in Tamil Nadu. Apart from that, near to Bangalore, we have a radio observatory. Gauri Bidanur is the place. And definitely in Ladakh, in a place, wonderful place known as Hanle, we have this famous Indian Astronomical Observatory. This is one of the most beautiful astronomical sites in the world. So if I come to my own place, well, this is the place from where today I am talking to you all. This is my home at present. If you want to read about the history of this place, you can go to this article. So basically this Vainubappu Observatory you see, as I was telling, it is situated, so we people, we astronomers of India lovingly call it, this is the telescope town of our country, telescope town of India, because you see so many telescopes in this huge area of around 100 acres, full of jungle. So if any one of you want to visit this observatory, from an institute or an organization point of view, you are always allowed to come. Definitely you have to write a mail, and prior permission is necessary because this is a restricted zone. But if you take prior permission, you are allowed to come. Anyone, any Indian, even if you are from outside India, if you want to visit this place, this is allowed. You can come with prior permission. If any one of you want to visit this place single-handedly, okay, I want to take my parents and I want to visit, please write a mail at least 2 months ago, give your plan, and please give an academic reason, because see, this is a place for academic research. So if you are just telling that I want to go there, I want to just do some picnic and come back, that will not be entertained. But if you give some academic reason that I want to study, I want to learn how these telescopes are working, I want to see how these telescopes are functioning, then you are welcome to come. And for any institute, for any organization, if you want to visit this place, please write a mail. You are allowed to come. At least 1.5 to 2 months ago, write a mail, because it takes time to get approval. You are allowed to come. So welcome to Vainubappu Observatory. Definitely visit once to see one of the greatest marvel of Indian astronomy. So many great discoveries have taken place from this place. This observatory is one of the oldest and at present the largest astronomical observatory in India. But I'm considering the optical astronomy. However, apart from this astronomical observatory in Kavalur, we don't have anything else. How these big telescopes are, if you go to any of these domes, you will see there are big telescopes. How big those telescopes are? Suppose you see there is a dome which is open here. If you go inside this dome, this is a 5-story building. If you go inside this dome, you will see a telescope like this. See the people who are standing, the engineers, the people who are standing in front. This is a huge telescope. We call it a 40-inch Carl Zeiss telescope. So this type of heavy, huge, fantastic things with these type of instruments, we can do proper science. Come to this telescope, the largest telescope in our observatory, the Vainubappu telescope. So 93 inch is the diameter of the mirror. See this telescope inside, see the whole structure containing the telescope, its other electronic equipments, control systems, and in front of this, see the people who are standing. So this is how the large telescopes are. So this Vainubappu telescope till around 2015 was the largest optical telescope of Asia. At present, it is the 3rd largest. And I'm proud to say that all 3 largest optical telescopes in Asia are in India, basically. So apart from our IIA, we also have different other organizations having their own observatories. I was talking to you about a fantastic place, that Hanle, Ladakh. If you go to Ladakh, you will ultimately land in this airport. You see already almost very few people stay there. Huge cold, high altitude, cold desert. And if you gradually move towards the China border, gradually you will see nothing is there. But almost towards the end of China border, you come to a small village known as Hanle. And there lies this excellent observatory, Indian Astronomical Observatory. At present, it is a very restricted, wonderful place. It is regarded as the first Hanley dark sky reserve. It is a dark sky reserve like reserve forests, like national forests. We also have in India a dark sky reserve to protect the dark sky. You cannot go to this place and suddenly switch on your torchlight or your mobile light, or you suddenly cannot switch on your vehicle light. You will be punished according to law with huge fines. So apart from IIA, as I was telling, go to this place, Nainital, Uttarakhand. See, you will see before reaching Nainital, around 10 kilometers before reaching Nainital city, there is a whole hill, which is known as Manora Peak. This whole hill is actually belongs to an institute known as Aryabhatta Research Institute of Observational Sciences, ARIES. And this is also an observational astronomy related top class institute of India come Asia. I was talking about the largest telescopes of India or Asia. See, they also have 40-inch telescope, and even the largest optical telescope of Asia is this one, 3.6 meter Devasthal optical telescope. It belongs to ARIES at present. So like this, we definitely have certain top level observatories, astronomical places where people can work, people are doing work, good work. There are so many others. I'm not going to every institute. So just to give you a glimpse, apart from optical astronomy, my friends, optical astronomy means what? Means the light which our eyes can detect. But when we tell the term light, it is actually light. What is light? It is a type of energy. It is technically known as an electromagnetic energy. Now this energy is having a huge range from radio waves to gamma rays. If you hear about gamma rays, infrared, microwave oven in your home, that microwave, X-ray machines, that X-ray, radios, that radio, all this comes under the same term light. Basically, light is having a huge range from radio waves to gamma rays. And inside that huge range, our eyes can detect only a few portion, this much portion, little bit portion. Just expanding it, it consists of 7 colors. And that portion is known as visible light. So human eyes can detect only a few portion of the whole light range, the electromagnetic frequency or the wavelength band spectrum. The visible spectrum is, or the visible range is only very few, considering from 4,000 angstrom to 7,000 angstrom wavelength. This much is only known as visible light. But you might ask a question, okay, if our eyes can only detect electromagnetic radiation within only this short span, this is visible light to us, then what if an astronomical object is radiating or actually giving out some other types of rays, microwave, gamma rays, X-rays? Yes, they do give. Almost every astronomical object actually does not only emit in visible light. Apart from visible light, they also emit in ultraviolet. If they are hotter, if they are hottest like black holes, they emit in X-rays, gamma rays. They are cooler objects, they can emit in radio waves, microwave. Then what is that? That means that this is a trouble. Then if I am trying to characterize, if I am trying to know the universe just by this much of light which we can detect, and all this light is moving away from our detection limit, that means we are almost blind. So it's like that condition that blind people trying to understand how an elephant looks like. And that is the same situation for us. So what we have to do, we have to design telescopes or instruments which can detect not only visible or optical light, it can also detect the light which is beyond our eyes detection limit. That type of detection is also possible nowadays in modern days. You see this simple picture. The second picture is of sun using an optical telescope. With our naked eye also, if you look at sun, it will look like this. Please do not look at sun with naked eye. It is extremely dangerous. But if you take the sun's picture using an optical telescope with proper filters, you will see sun like this. Do you ever believe, looking at this picture, that sun is a burning ball of gas? I cannot believe that. Maybe you will also agree with me. But same sun, you take the picture of sun using an infrared telescope, now you see the first picture. Something like burning or something like hot fire is appearing to our eyes. Same sun you see with an ultraviolet telescope, this third picture. Now you see, okay, sun is looking almost like a burning ball of gas. And actually sun reveals its actual glory if we see sun with an X-ray telescope, the green color. So now you can understand, oh my God, sun is very dangerous. It's a burning ball of gas. Something is coming up. And fire is coming out of sun. So basically, if our nearest star sun is hiding its actual glory or actual image or actual face, if we only look through our naked eyes, think about the whole universe. The universe is very, very big. So we have to design, that is why we have designed telescopes, instruments which can detect electromagnetic rays coming from different bands, different radiations, apart from optical. We need telescopes to detect all this type of light. And these type of telescopes will not look like those simple, wonderful, standard tube-like telescopes which I was showing till now. For example, let us come to India. This, you see an array of antennas, very huge antennas these are, and very powerful. There are 30 antennas spread over an area of around 30 square kilometers. All these antennas are huge. From here to here, it is 45-meter diameter, huge antennas. And these all antennas combined together with electronics makes one of the most powerful radio telescope systems in the world. It is known as, proudly, it is a pride of India. It is known as the Giant Meter Wave Radio Telescope. It is situated in a place near Pune, around 90 kilometers away from Pune. It is under which institute? National Center for Radio Astrophysics, which is also based in Pune. So basically, this is how astronomy has revolutionized. I was first talking about some simple naked eye tool. Our tool was naked eye. Then it came to huge machinery, stone-built objects or instruments. Now think about these instruments. With these instruments, you can actually see the sky the way we actually understand the sky. So without going to much details, you definitely know, apart from these instruments which are present in our own Earth, we have telescopes and instruments, satellites which are present outside Earth also, like James Webb Space Telescope, Hubble Space Telescope, different other telescopes are there. So combined, this whole weapons combined together actually help us to study astronomy in a wonderful way. The question obviously will come, why we should study astronomy? Definitely it is a fun. Definitely it is the most thrilling subject in the world which I can think of. Maybe apart from human body, means medical science, maybe this is another area, astronomy. Maybe these two are the most fascinating subjects, most mysterious. So many things we do not know about these subjects. So for curiosity purpose, we have to study astronomy. But apart from only curiosity, as I was telling, astronomy is very much important for the development of humanity, for the development of human life, because it is the subject which tells us how nature works. It is the subject which gives us the possibility to study the most extreme natural laboratory. We cannot have that kind of extreme phenomena, extreme situations occurring in our Earth, which we have in outer space. Definitely, if we study astronomy in a broad way, then the best application of scientific knowledge can be done in astronomy subject, and we can come to know whether our theories are correct or not. About physics, about mathematics, about engineering, about technology, we come to know. And all this combined together, if I say that astronomy study makes our lives more comfortable, maybe some of you will start believing this, because I have already told that even during ancient days, by looking into the sky, by studying the sky, people started understanding that it is not mere curiosity. By studying the sky only, we can make the first clock, we can make the first calendar, we can make the first map, we can make the first direction compass, and we can also predict seasons. We can also live a comfortable life, not a dangerous life. We can predict when flood will come in Ganges or Nile. So till now, this is actually highly valid. To make our life more comfortable, astronomy is necessary. And also, we human beings are in Earth, and Earth is itself a planet in huge space. To know about our home, to know about ourselves, how we ourselves came to Earth, we have to study astronomy, my friends. Well, let me give two small examples. I was telling that extreme laboratory, the most extreme laboratory we can get if we study astronomy. How? What is an example? Take this simple example. Take this. This is a picture of sunset. Sun, and I have told sun is very dangerous. How will you know that? Well, take the picture using an X-ray telescope, and through X-ray telescope, it's a videograph actually. You see, actually sun is dangerous. Fire is coming out. These are known as solar flares. So this fire which you think is coming out, it is not small. It is very, very dangerous, very huge. How big? Well, the second loop of solar flare which is coming up, this second one, it was possible to take the picture of the second flare and see this picture, how big it was. Just in front of that second huge solar flare, if we put our Earth is like this, a small chota sa ball. If some amount of fire, little bit amount of fire of that solar flare would have reached Earth in that day, then the whole Earth would have evaporated within a second. Now, looking at this picture, what we can think, what generally we can think of, oh my God, that means sun is a very superb star in this universe, right? But my friends, no, sun is a very mediocre star. Have you ever wondered which is the largest stars in the universe? How big those stars are? Well, let me give an example. The way we have given the example in this picture, now if I place our sun in front of the largest known stars of the sky, how big it will be? For example, this star, NML Cygni, no need to remember the names, just I am giving an example. This star is so big that if I put our own sun in front of it, it will look like a dot. It is so big that 700 crore suns will fit inside one star. And our sun is so big that 13 lakh Earths will fit in our own sun. Now you compare. 13 lakh Earths will go inside one sun, and 700 crore suns can go inside this star. This type of extreme laboratory we will never get in our Earth. Impossible. So to know how nature actually works, from smallest scale to the largest scale, we have to study astronomy. And as I was telling, okay, to make our lives comfortable, we have to study astronomy. We'll take another example. Apollo 11, the mission which took human beings to moon. Many people might ask you, okay, what was these three people went to moon, okay, very good, we were very happy. But what happened after that? Means, well, what was the benefit for common man by spending billions of dollars? Just sending man to moon, fun, curiosity. No, my friends, if you don't know, then only you will ask this type of questions. It had huge implications. Just for sending man to moon, just to make Apollo mission successful, so many inventions have come. Some few examples I am showing here. Just for sending Apollo missions, something known as house insulation system came. And nowadays you are standing, all of you are sitting in some flats, maybe some multi-story buildings or offices. What is the guarantee that a thunder strike will not happen? Because your house is insulated. And that modern house insulation came not because of us, but because of sending man to moon. People who are staying in cities where we have water having arsenic problem or some water is not pure, we use water purifiers, aquaguards. That water purification process was also invented for these people, sending man to moon. And think about these things. In medical science, unbelievable. Gas analysis, programmable pacemaker. This programmable pacemaker from that day onwards have saved millions of lives in the planet. So many improved kidney dialysis machine. It has also saved more than 1 crore lives, maybe more than that in the whole world from 1970s onwards. So there are so many, this same list can go on continuing. I am just giving a spin-offs. So just to send man to moon, how many important discoveries happened, which we people are taking advantage today without knowing that all these discoveries came through the hands of astronomy. So it is actually true that if we study astronomy, actually it makes our lives comfortable. Today, all of you who are listening to this talk, it is because we have satellite technology, because we are all meeting, we are talking using online mode. How this is working? Satellite technology, which also came through astronomy. So this is why astronomy is important, but the problem here is this. Till now, how much we know about the universe? We know very little. Actually, the whole universe, if we map, we have seen that we can only see 5% of the universe. The rest, 95%, consists of something known as dark energy, a mysterious form of energy, and a mysterious form of matter known as dark matter. So after hundreds of years of so much studies also, if we know only 5% of the universe, then we can understand that it is much required that we have to understand, we have to study astronomy, because if only 5% we can see basically, and that has given us so much comfortable life. That has given us satellite technology, mobile phone, internet, so many things. So if we know much more about, more than 5%, if we know, that will definitely help us. So basically, someone in a funny way told, your future will be bright if you study the dark universe in future. And this is why we have to study astronomy. So if you people, if the students who are present, well, if you want to study astronomy, what you have to do? I definitely want to give a guidance, taking this opportunity of this talk. So maybe I will take these 5 minutes to give you a guidance, what you have to do if you want to become an astronomer. First of all, you need these 3 P's, what I generally tell as 3 P's. You need not have to become brilliant. You did not have to become excellent or unbelievable brilliant or extraordinary brilliant. If you are, then definitely it's an advantage. But if you are not a brilliant, you should have these 3 P's: passion, patience, and punctuality. Without these 3 characteristics, you can never ever become a good, honest, dedicated astronomer who will ultimately able to contribute. And I believe this is not only for the case of astronomy. If you want to become a hardcore researcher, professional researcher in any field, science, commerce, arts, whatever, if you want to become a researcher, you need these 3 qualities. Apart from that, if you have other qualities like this, gradually start developing fundamental knowledge. Read and read. Nowadays, if someone comes and tells me that, okay, I cannot know astronomy because I don't know how to read it. My friends, internet is there, Google is there. Read. Books are there. Books are very much available to your door if you order a book from Flipkart or Amazon online. When I was a child, nothing was there. All these things were absent. So nowadays, if somebody comes and tells me, okay, I don't know about solar system because I don't have any access to library. But internet is there, my friend. Instead of taking much more time in playing internet games or watching movies, give some time, that is also important, but apart from that, give some time in reading and developing the fundamental proper knowledge about astronomy as much as possible. That is why I have written this. To read popular astronomy books, popular science books, use internet wisely. You can use the same internet to make a bomb, but a wise person can use internet for gaining wonderful knowledge about some subject, for some constructive work. Do that. And definitely people at present, India is also standing in a good place in astronomy. Astronomy is increasing rapidly in India. So try to visit nearby science centers, planetariums, museums, as much as possible. Try to take part in this type of talks. If there is any course, try to take part in that. And these all things will ultimately help you to know the information you are gathering, which is authentic information, which is not. So if you think that, okay, Wikipedia is written by everybody, so I will not follow Wikipedia. You don't know something, some data which is present in Wikipedia is correct. But how will you justify, how will you know that? All these things will help you. Knowledge is the power, and that is why this slide I have made. And only knowledge will not help you if you don't have these three qualities. So apart from that, now if I go to, okay, how will you start developing astronomy knowledge? Try to join some amateur astronomy organizations. Try to join some amateur astronomy clubs. Nowadays, there are so many amateur astronomic organizations, clubs across India. So 20, 30 years ago, this was not the situation. So because these clubs will help you in discussions, they arrange camps, they arrange workshops, they arrange discussion sessions, seminars, symposiums. These type of activities will give you a wonderful opportunity to learn astronomy, basic astronomy. And for example, I will show you this particular one example. This is Jyotirvidya Parisamstha, the oldest amateur astronomy club of India, which is in Pune. It started from 1944, before independence. So like this, now it is your duty to search. Go to internet, wherever you people are staying. Suppose somebody who tells, okay, I'm from Delhi, or it's a very big city, very nice. Okay, I'm from Calcutta, again a very big city. But somebody who is telling I'm from village, somewhere near to Maharashtra, okay, very in remote place. But go to internet and search near to your place, where is the nearest clubs like this? How you can become a participant of these clubs? Where is the nearest planetarium? Search this out. That exercise is necessary. Now after 10th and 12th, what you will do? If you want to become a professional astronomer, definitely you have to go to science. You have to take science. You have to do your graduation in science, and physics should be a mandatory subject. After your graduation, after your BS, the new NEP has come. So after your BS, you have to go to either masters in astronomy or physics with astronomy as an option. And during your master's time, try to involve yourself in some research projects. Research projects or internships, visiting student program, in some reputed institutes with some top level astronomers or researchers who are doing research in top institutes like IIA, IUCAA, ADIS, and that type of opportunity is given by them. Every year that runs, do that. And ultimately your goal will be to join PhD. If you are PhD in astronomy and astrophysics, then only you will be called an astronomer, otherwise not. So basically, to become a formal astronomer, this is the route. You have to go through a very rigorous journey of knowledge. And for that, you have to have patience, you have to have passion, you have to have that understanding that, okay, I have to go on continuously doing hard work punctually, and one day success will definitely come. And my friends, during this new Gen Z age, I would like to say, please don't take my words in a bad sense. We are watching, every day we are watching that when more younger and younger people are coming to us for getting projects, for doing research projects, we are watching that they are all into, maximum of them are not having these three qualities. Some of them are really, really intelligent, super talented, but those three qualities are missing. Either passion or punctuality or patience, these are missing. If any of this is missing, I can vouch that you will not become a good astronomer. So basically, you should remember, sometimes you can achieve success by shortcut, but superior success you can never achieve by shortcut. Becoming an astronomer is a superior success. Well, which are the institutes in India, top institutes in India, where astronomy is practiced or astronomy is offered in PhD, master's level? These are some of the institutes. There are so many. These are some of the institutes. IIA, Indian Institute of Astrophysics, IUCAA, another big place. Inter-University Center for Astronomy and Astrophysics in Pune. ADIS, I have told, Nainital. Then this is in Calcutta, S.N. Bose National Center for Basic Sciences. They are also very good in astronomy. You see, I was talking about National Center for Radio Astrophysics in Pune. This is dedicated to radio astronomy. This is a fantastic place, very memorable place, IISC. Indian Institute of Science in Bangalore, and definitely this one, IIST, Indian Institute of Space Science and Technology, the only space science related university till now in Asia. It is in Trivandrum, India. So how will you know? Well, if I give you a glimpse, how will you know that what are the major institutes in India for astronomy and how I can join that? What is the exam I have to give for PhD or for higher studies? And what are the courses, what type of areas they offer? In that case, please come to internet. This I am just giving you a glimpse so that you know. Come to this place, go to internet. Come to this place, Joint Entrance Screening Test. This is the website. Go to this website. Joint Entrance Screening Test is the exam, apart from which there are other exams like NET, GATE, but this is also another exam which you have to give for becoming an astronomer. If you want to become an astronomer and you want to do PhD or post in astronomy in these type of top institutes in India, then this is one of the exam, one of the major exam, Joint Entrance Screening Test. Which are the institutes which take you by this exam? You click here, participating institutes. Just click here. You will see all the names of the institutes. Aries, Bosch Institute, all this. All the institutes will come. Indian Institute of Astrophysics. If you want to check, okay, I want to see, okay, suppose Izar Mohali. In Izar Mohali, what are the research areas they offer? Click here. See the research areas. Can you see astronomy, astrophysics? Solar and plasma physics, see. That means astronomy is there. Theoretical particle physics, so astroparticle physics is there. Matter physics, condensed matter physics, which is related to astronomy also. Now, if I want to see, okay, what are the some institute where I will only get astronomy, nothing else. Well, then you come to these institutes like you see IIA, Indian Institute of Astrophysics. What they offer? Astronomy and astrophysics, optics, atomic physics, astronomical instrumentation. You can go to their website just by clicking here. Click here, go to their official website. You see, everything is given. Everything is there. Who are the people who are, what type of research they do? Who are the people who are doing research? The academic people means the scientists and the postdocs. The students means the PhD scholars. The technical instrumentation and engineering team, admin people. Everything is there. Everything is there, my friends. What type of opportunities you will get? You see here. This I was telling. Internship program. Opportunities, visiting students is internship program. Go here, internship program. Well, this is the whole process. So what I am trying to tell you is I'm not trying to teach you what is astronomy today. I'm just giving you a glimpse, my friends, that there are ample opportunities nowadays. Try to grab it. And one day, if you grab these things in a good way, you will get some benefit. Apart from that, if you want to start doing some astronomy, some contribution to astronomy from today itself, there is another platform which is known as citizen science. Means any amateur person, anybody can contribute in astronomy up to a certain sense using this particular worldwide project. It is a free project. It's citizen science. That is why it is known as citizen science. It started with astronomy projects. And how will you come to those projects? Before that, you should know that astronomy is one of the very rare subjects where basically amateurs can contribute hugely. So some of these names you see, Copernicus, Bruno, Galileo. So they were actually amateurs. They were not professional astronomers like us. So astronomy is one of the very few subjects where amateurs can really contribute. So amateur astronomy, if you want to do in a good way, definitely you can do. Now we have citizen science. Suppose what you can do, suppose come to this type of stars. There are stars which vary in brightness. And these are known as variable stars. You see this is the pole star. Even our pole star varies. You see sometimes it becomes brighter, sometimes dimmer. And you see other types of stars, due to many reasons, stars can vary in brightness. So collectively, they are known as variable stars. And it is very important to study variable stars. Why? Because variable star research provides us information about evolution, properties of stars. Even the expansion of the universe is expanding and accelerating. This also came through studying variable stars. How our sun will end its life. That also we can understand by studying a type of variable star. How we can measure distance in the universe, that also came from studying another type of variable star known as civet variables. So studying variable stars is extremely important, and that is why there are so many variable stars, right? So it is not enough. The number of professional astronomers is not much in the world. 1 out of 15,000 or 14,000 people in the world actually becomes an astronomer, professional astronomer. That is very less. And that is why the citizen science concept came. Basically, there's a platform, you see, American Association of Variable Star Observers. This is the website. You can go here and you can register your name and you become a member of APSO. So 100, more than 100 year it is continuing. What you can do, they will give you you can observe a variable star. You can study the behavior of any variable star if you have a small telescope, and you can actually submit the data in this particular database. And this database becomes larger and larger. So this is how in future, if you are an amateur astronomer, you might not become a professional, or you don't want to become a professional, but you can contribute. So by studying this variability, professional astronomers who are studying variable stars get huge help in future. So this is one way. But you might tell, okay, I don't have a telescope, what I should do? Then come to this platform, Zooniverse, zooniverse.org. This is the platform where all top level citizen science projects are all given. So in every language you will see, basically every subject. So you come to this space, the last one, and you click in space, you will see there are more than 20 astronomy related projects which is running now. You can join any of this project. Just join any of this project and you can contribute in real astronomy research up to a certain level, free of cost, without having any proper background of astronomy also. Even the contributions of amateur astronomers in citizen science has ultimately helped in the publication of number of published papers, proper authentic papers. So this is one example of a citizen science project. Disk detective. This is a project in that Zooniverse platform. I was also I was interested in this project, and today I am a professional astronomer who actually studies stellar disks. So this project gave me that motivation to make my whole life dedicated to study stellar disks. So here you will be studying disks around stars where planets are formed, using a mission, NASA's one of the mission, which is WISE mission. It is in space. It is a telescope in space. So I'm just going a bit fast. Now, using this particular disk detective project, you see this is a paper which is published. There are so many other papers which is published. And see the affiliation, the number 6. Number 6 is, who is this person? He is not an astronomer like here. They are all professional astronomers. But number 6, you see disk detective citizen scientist. And see how many are like this: Hugo, Katharina, Joshua, Jonathan, so many, you see. Alexandru, Mishiaru, so see Joseph. So see, in the whole list of these authors, most of them are basically amateur astronomers, and is known as the disk detective collaboration. If you want to start this type of initiative, can you start this? Can you join? Definitely you can join. If you want to know how many citizen science projects from NASA has published papers, go to this website. Go to this website from NASA related citizen science projects. How many publications have come? You just click here, publications, you will get the full list. It's very motivating. In India, do we have any citizen science astronomy project? Yes, it is there. The first astronomy citizen science project which started in India was by a person known as Professor Anand Hota, wonderful astronomer at present. In 2013, he is a radio astronomer, so he started a project known as RAD at Home, Radio Astronomy at Home. But for this particular project, to join this project, you need to be a graduation student. It is a bit technical project. If you are not a graduation student and want to join some Indian astronomy related project, citizen science, then we have a project, Indian Institute of Astrophysics, with collaboration with another organization known as Pune Knowledge Cluster. So we have a project to classify the features of galaxies, which is known as 1 billion galaxies. So this project also, you can go to this particular website. time to time, when data comes, we upload the IIA and PKC, they upload the data, and then you can join this project free of cost. Every guidance is there. If you go to get started, what is a galaxy, what are the features, how will you do the project, everything is given there. And you can ultimately start contributing. So basically, if you want some guidance, okay, I don't know, I am a class 5 boy, class 8 boy, I don't know, I don't have exposure, I just want to take some guidance that is there any group we can join and we can take the guidance how to do amateur astronomy related such type of projects. There are groups like this, like International Astronomical Search Collaboration. They search actually asteroids, nearby asteroids. So this is a worldwide collaboration. And from India, the first asteroids which were found using citizen science, this IASC collaboration, were these two class 11 boys from Delhi Public School in 2011. Apart from that, the easiest way if you want guidance is to go to this group, SA Citizen Science Group. This is an India-based group, WhatsApp group, a group of citizen scientists dedicated to astronomy-related projects in India. This is the WhatsApp number. You can just talk to the person, Mr. Shobhan Acharya. So he's the admin of this group, the founder of this group. You can tell, okay, I joined this talk and I was interested. I want to join this group. Nothing you read. And I want to contribute in citizen science in astronomy. So I need some guidance. So this is a huge group. At present, they are guiding over 20 projects. There are more than 3,000 volunteers, more than 400 WhatsApp members, almost all over India and also from abroad. So you can take the help from this group also, the Citizen Science Group of India for astronomy. And from this group, if I say, this is in Bengali actually, NASA's youngest citizen scientist became a student of class 4, Arush Noshkar from Kolkata, becoming a member of this particular group. This is the boy. At present, it is 2 years ago, 3 years ago this happened. So what he did, he helped in the detection of 5 asteroids. 5 asteroids. So that means if somebody tells, okay, I am in class 6, what I can do? Definitely, my friend, you can do. Somebody tells, okay, I am 85 years old, what I can do? Definitely, my sir, my madam, you can do. There are so many such members in this Indian group who are contributing good. Think about this person, this boy, Shaurya. So again, if you think, okay, from Calcutta big city, so that is why Arush can do some good work. This boy is not from a big city. He is from a place from North Bengal known as, the place is Malda, very famous for mangoes all over India. So he was in class 6 when he actually started searching for these asteroid candidates, and ultimately he got recognition. What about gender bias? Definitely, it's not only about boys. Think about this girl, class 5 or 6 girl, and simple girl. So even research papers have come out from the members of this group, like you see the last name Shobhan Acharya, the founder of this group. So if you can ultimately contribute really good, then even in research papers, you will get your names. These journals are extremely excellent journals in astronomy. One of the topmost journals of astronomy, monthly notices of the Royal Astronomical Society, APJ, ANA. These are top level journals, Nature Astronomy. So getting a paper in this type of journal is a real achievement. So for a professional astronomer, it is our duty to publish papers. We have to do it. But for an amateur astronomer, getting a paper, getting a name, authorship in such a paper, this is a real good achievement. So my friends, what I wanted to showcase from this talk today, overall, the summary, the takeaway point should be that forget those ancient days when people used to just look at the sky without understanding anything. Now we have come to a place, if you want, regardless of your age, religion, caste, subcaste, regardless of your even financial condition also, you can actually contribute in astronomy. And if you are serious enough, if you are dedicated enough, if you love this subject, you can move forward to become an astronomer in future. And we need astronomers because we come back to the same point. See this huge sky, so many stars, and we understand very less. So we need to study astronomy. Why I have already explained. And how to study astronomy, I have given a glimpse. Where to study, how to study astronomy, that also I have discussed little bit. If you have any other queries, please definitely come up. Thank you everyone for listening. I have already taken more than 1 hour, so I will definitely try to take some open discussions or questions, because that is important, I feel.
Thank you so much, sir. This was a great session. I think we have a time constraint, but let's take a couple of questions from people so that their queries are clear. One thing I would like to tell you, please be limited to one question each person so that everybody gets to take a question.
Sure.
Soumya, you can go ahead and ask your question. Let me just open your mic and camera. Please open your mic and camera and go ahead and ask your question. Soumya.
Hello, sir. Am I audible?
Yes, Soumya, you are audible. Yeah. Hello.
So, very good evening. I totally loved your session. It was very enlightening. And I myself want to pursue astrophysics as my, career in the future. I have a question regarding spectroscopy. Can you tell me what are the possible challenges in stellar spectroscopy that can be studied as research problem?
Okay. Yeah, a wonderful question. Actually, I study stellar spectroscopy. I'm from stellar spectroscopy only. And so basically, yes, stellar spectroscopy is one of the most interesting, most challenging, most fascinating areas of astronomy. But there are, as you are asking about challenges, if you are in college level, I believe that you are in college level. So you will see, there are so many certain things which we do not understand even about after studying astronomy for years. For example, I was talking in our area, we study stellar disks, how these disks form, how they evolve, what these disks or what these gas particles or dust particles tell about their evolution. And by studying these gaseous or dusty disks, we can also understand how gas particles behave at extreme temperature, which we cannot do in earthly conditions. So this is one way. So that means in basic physics, in general understanding of basic knowledge of physics, one part is how gas particles behave. We actually do not know how gas particles behave at extreme temperature. For that, we have to study some particular type of stars, which we study actually. And so that is a very specific area which we focus into. And so these are known as emission line stars. So to understand how gas particles behave at extreme temperature, we have to study those stars. They have gaseous disks. So this is, I am talking, just one example I am giving from our own area. But think about star formations, death of stars, supernova, nova, all these aspects can be, even the galaxies, going away from stellar astronomy, even the galaxies. So there are ample amount of things which we need to know, the evolution, the origin, how they behave, how single objects like stars behave. For all these aspects, we have to go to spectroscopy. And that is, so whatever we know, when we know something, we become happy and we see 5 more unknown questions coming up. So it becomes a all-time effort actually. So this is one challenge I have told, but overall, stellar and astronomical spectroscopy is one of the largest, most favorable tools through which astronomers can understand the physics, history, geography, and physics of chemistry of the universe. So in every area, there are unknown questions. So we have to study that. Yeah.
Sir, and if I want to start my undergraduate research, like literature review, what area do you think I should start with? Because I'm getting quite confused.
No, that will depend on, so that was I was telling you, read. That will depend definitely on which area you are interested. So if suppose I will suggest go to some basic astronomy related books or go to some basic astronomy related website in a small way and try to understand which area fascinates you the most. Suppose is it solar system? Is it astronomical spectroscopy? Is it stars, the evolution of stars? Then you can start, okay, I am more fascinated into, why I am into star? Because I became more fascinated into studying the stars. Oh my good, the star which I can see, I can study that. I know how it behaves. That became, I became much motivated. Not today, many years ago. So that's why I thought, okay, I will take stellar astronomy as my career. I like that. So spend some time to do that. And as you have asked this question, there are so many students. Let me show you one example. Well, how will you start studying suddenly? Well, there is one authentic astronomy Wikipedia which is present in the net. Let me show you this. Just, I believe that again my screen is shared, right? Somebody please tell yes.
Yes, sir.
Okay, now you see this, Teach Astronomy. Go to this, teachastronomy.com, click here. They will ask you some question whether you're a student or not. Just tell, okay, I'm a student. Okay. Suppose I am telling you, I always remain a student. I am always a student. So, okay, I am a student. Then go to this textbook, chapter layout. And now you see the wonder. This is a 19-chapter complete guide for astronomy. And if you print these 19 chapters in a book, if you print it, it will be 1250 pages. And see how wonderfully it starts. What is science? What is measurement? What is estimation? What is mass? What is observation? And gradually, what is geometry, logarithm, testing, hypotheses? And ultimately, now it is going to chapter 2, early astronomy. What is night sky? What is motion? What is constellation? I was talking about constellation. You want to know something about constellation? Just click here. You see one page of full write-up. Very nice, very concise, almost no equations. Wonderful explanation. What is a constellation and how seasons form. Like this. So now if you want to, okay, I want to know about stars. Okay, the properties of stars. Okay, just go to this chapter. Properties of star. Okay, how distance of stars are measured. I just want to know this. Come to this distance of stars. Again, you see one page. Simple. I will suggest if any one of you can read this full Teach Astronomy textbook. It is not actually a textbook, my friends. It's a fantastic popular way of making you understand what is astronomy. If you can read it, you will never ask this question to me again. Yeah, you yourself will tell, okay, I am very much interested. I want to do planetary science. So thanks for asking this question so that I can show this to you. Please do this exercise. Please do this for yourself. Maybe for 1 month, 2 months. Then only you will understand which area you are more fascinated. Otherwise, you cannot suddenly start maybe origin of the universe. If you start writing something,
Yes.
you might not be interested in that after 1 month. So this exercise, this patient exercise you have to do. Yeah. Okay. Thank you for this.
Thank you so much, sir.
Yes.
Thank you. Archana, you can go ahead and ask your question. Archana.
So, sir, I had a question about gamma rays and X-rays.
Yes, Archana. Hi. Evening. Good evening. Tell me.
So, my question was, I have heard that gamma ray bursts occur in supernova explosions and are extremely dangerous for life on Earth. Even if gamma ray bursts occur at a distance of 10,000 light years, they can harm entire life on Earth and trigger a mass extinction event. But I have also heard in MRIs, doctors use gamma rays to scan human body. So if gamma ray bursts can destroy life even with the distance of 10,000 light years, then how does doctors use gamma rays in MRIs? Why don't these gamma rays kill that person?
Wonderful question. Very good question. So you are in college? You are in school or college?
Sir, I'm in school. I'm in class 8.
Very good question, Archana. Yeah, see, the gamma rays which we are talking about, so this gamma ray is gamma ray, but the gamma ray which when you are talking about the gamma ray bursts coming from outer space, from magnetars, from supernova, from colliding of two black holes, that the energy which that gamma ray burst carries is much unimaginably more than the amount of energy we use in X-ray machine or gamma ray machine for analysis of our body. So for just to give an example, you see when a gamma ray burst happens, so we are till now not sure whether from 10,000 light years it can affect Earth or not, because that we are not sure. But if this type of supernova happens nearby, suppose when Betelgeuse bursts, it is around 600 light years away. We don't know what will be the effect on Earth till now, or whether gamma ray will come from that. If it comes, what will be the effect? Yes, because 600 light years, we consider it is comparatively much nearby. But 10,000, 20,000 light years, it might not affect the whole life system, but definitely it can affect the ecosystem, the Earth's higher atmosphere, ionosphere, and that has happened also. So that has happened at least once in our lifetime. Now, what type of, how much energy a gamma ray burst carries when a supernova happens or a collision of two black holes take place, within a second, the energy a gamma ray takes, within a split second, the energy a gamma ray throws, a gamma ray burst, the total energy is much more than the total energy that will be produced by our sun, maybe for 100 crore or 200 crore years. Within a split second, that energy will fly through. So that type of energy, it's like a, you can understand, it's like some trillions of atom bombs passing together at a second. If it hits you, if it hits any place nearby, that whole Earth will be evaporated. But the amount of gamma ray which is used for, or X-ray which is used for our body medical purpose, that is much small. Think about energy within a split second. The total energy which is coming is much more than the total energy sun will produce in all electromagnetic spectrum or radiation for 200 crore years. That much energy, if it comes, it is extremely dangerous. But what will be the resistance? What can be the effect? That will, so there are scientists who are studying gamma ray bursts. So they are trying to understand the effects. Yeah, but very good question. Yeah, thank you. Okay,
Sir, I had one more question that you can say that the friction occurs in gases.
Yes, friction will occur inside any matter. If there is matter, if you want to walk through that matter, friction will take place.
And
it
sir,
can be small, it can be big, large.
And sir, I had one more question that as we know that the temperature of the sun is 5,504 degrees Celsius. And in that temperature, the gas no longer exists. It turns into plasma. But near a quasar, the temperature increases to many trillions of degrees Celsius. So how does gas do not change its state? Means how does gas remains a gas? Why don't it becomes plasma?
It becomes plasma. Actually, it becomes plasma. Yeah. So the gas which you are watching may be coming from the quasar, that portion of that quasar, gradually we see the gas which the torus, the gaseous envelope which covers the quasar. Yeah, so that is gas which is hot, but it is in plasma stage. It can be in super condensed stage also. Yeah, so when you go above, so apart from the gas which we naturally call, we see this is gas or plasma. Apart from that also, we can produce gas at much higher temperature. But that gas property will be little bit different or absolutely different from the normal gas. So when you go above in higher classes, you will read about these things. Non-degenerate matter, degeneracy, then ideal gas. What is an ideal gas?
White dwarfs, degenerate matter.
Yes, so these are absolutely different. So if you go to an white dwarf, you will see, we will call it as a degenerate matter. But that matter will remain in the form of gas, yes. But that gas and this gas is absolutely different. That is degenerate matter. So that is beyond plasma, beyond our classical mechanics and classical understanding of physics. We have to understand that through different type of physics, like relativity, like degeneracy, like quantum mechanics, quantum physics, all these things. Yeah, so that is also there. But okay, now I will thank you, because I will take some other questions also. Let others also get chance. And very good questions, Archana.
Yeah. Okay, sir.
Yeah.
Very good questions. Thank you. Mehak, you can go ahead and ask a question.
Okay, am I audible, sir?
Yes, you are audible. Yeah.
So, sir, my question is, I am recently going to join Plasma Physics Research Institute for PhD, and I want to know that how can I connect my plasma topics with astronomy? Means, can you recommend me some topics which I connect to the plasma, since I am interested in astronomy also?
See, as I am not specifically working on plasma astrophysics, but there is plasma astrophysics. So any area where we were discussing, any area where some hot matter is there, hot gas is there, or astrophysical disks are there, very hot astrophysical disks, you have to study plasma astrophysics. So any stellar gaseous disk, any astrophysical disk phenomena, if you have to study in hot conditions, that mostly it will be, the gas will be in the form of plasma, mostly. It might not be in case of protoplanetary disks. So plasma physics you can connect if you have some plasma astrophysics related area, like study of astrophysical hot disks, study of astrophysical hot matter coming out from astronomical objects. So what I will suggest is you read some you read some papers, search some papers related to plasma astrophysics and read some papers. See what type of works they are doing, the recent people are doing in various areas of plasma astrophysics. And all these questions, these are very important questions you people are asking. Okay, if I want to do something, if also I am watching one good question in case of the chat also, somebody, Rakshit has asked a very valid question. Sir, how does astrophysicists earn? So astrophysicists will earn by being an astronomer, by being a scientist of those type of top institutes. Yeah. So we can become an astronomer and earn by becoming an academic. So astrophysics mainly is an academic line. Yeah, so either you become an astrophysicist or astronomer and become a scientist in a top institute, or you become a university professor in astrophysics and astronomy. Or you can also join some industries related to astronomy instrumentation development. These are all coming out. You can also start your own business. All these are all becoming bigger. Yeah, so earning is definitely good. If you have your own business, then definitely you can earn a much more. So that will depend on this. Now, for all these questions, I will suggest all of you, as you all are now young, try to visit some conferences. Try to at least visit the one particular conference that is known as Astronomical Society of India Annual Conference. See, it's Indian astronomers ka big conference, and all Indian, maximum Indian astronomers meet at some top institutes every once in a year for astronomy related conference, discussion about astronomy, discussion about different types of astronomy works which is happening in India. There are posters, hundreds of posters from different institutes, different research scholars come. Do visit that place once. How will you visit it? Okay, just I will again show an example. When this question has come, I am sharing my screen. Just see this. So this year, this conference happened in case of IIT Guwahati. So you just go to this place, astron.soc.in. This is Astronomical Society of India. Well, now you come to this meetings, ASI annual meetings. If you click ASI 2026, you will see this Astronomical Society of India meeting happened in IIT Guwahati just 1 month ago. And now if you go to home, you will see the next astronomical meeting has also been already declared. Where it will take place? Let me check whether it has given or not. Yes. Important. Yes. So basically, it will happen in IIT BHU. It will happen in IIT BHU, that is in Benares Hindu University. This is the thing. So 45th annual meeting of the Astronomical Society of India, it will happen at Varanasi when 12 to 16 February 2027. So anyone, specifically those who are already going to a graduation level, early graduation level, please visit this place. This will be an investment. So, okay, I want to, as Archana, somebody was asking right before this, how will I know which area I like? Go to this meeting and see so many posters will be there, so many talks will be there. It's not mandatory that you will understand every poster, but see what type of works they are doing. So just, this is a wonderful platform. Please come, please visit this place, and that will be important in your life. These things are very important. So this will help you, definitely.
Yes, sir. Thank you.
Thank you.
The next question was that it was the similar question that what are the astronomy jobs? Means recently I got to know that there was a job of telescope trainee at PRL. So
PRL, yes.
So are there any prerequisites required for it?
That you go to PRL, like you go to PRL, go to their job details, they
Okay.
will give. Like you go to IIA, you go to their opportunity section, job opportunities, see, just go to these surveys always, at least once in a week. It's good that you have found that job. So apart from PRL also, there are other opportunities coming. So research training or these jobs will come to you if you are not an astronomer. If you are an astronomer, you want to become a scientist, full-time scientist, then you have to become an astronomer. Definitely. So, but before that, yeah, this type of instrumentation related jobs, go to those institutes. Definitely go to those institutes. Even if you go to that Astronomical Society of India, that homepage, you will see
Yes.
there is a section known as jobs. Go to the jobs section. All jobs related to astronomy in India are posted in that
Okay, sir.
website. Yeah, so follow that. Yeah, yeah.
Yes, sir.
Thank you, ma'am. Well, next somebody wants to ask. Yeah.
Shrujil, you can go ahead and ask the question.
Yes, Vijay.
Hello, sir. Thank you for this interesting session. My question is that how is the shift from historical methods to modern AI changing our present discoveries?
Mhm. Definitely, AI and ML, these are extremely important. AI, ML, then modern computing technologies, and quantum computing. So basically, see, what I would like to say is, if you see, we are watching people, even if you want to write a thesis, suppose your PhD thesis, your research paper, if you take the help of AI and try to write, it will be wrong. Absolutely. You will be caught, and this has happened in my experience within the past few months, so many. Somebody did complete PhD, good work they have done, so that the person has done, and then for writing the thesis, he told okay, ChatGPT to write the thesis. उसने तो ChatGPT को लिख दिया thesis, but his PhD got cancelled. You're a cheater. Even that person didn't read what is written in the thesis. So, but if you are, suppose, if you want to do a good query, suppose I want to know how many stellar astronomy related, or I was telling the previous Mehak or somebody, right? Okay, just search. I want to know how many plasma astrophysics related recent papers are there. You ask ChatGPT, ChatGPT will give you maybe 10 papers, 20 papers. But reading that paper, what work is being done in that paper, that you have to read. That is manual. That is no way you can escape. Success sometimes you can achieve by shortcut, but superior success you cannot. And knowledge, there is no royal road for knowledge. So if you are using AI, ML in a good way, it is becoming a huge tool for us. It is becoming maybe after the discovery of telescope, it is becoming a great weapon for us. So we are using, even 2, 5, 10 years ago, we had to, suppose we had to study the spectrum of 1 lakh stars. So either you have to do it manually or you try to write a code. That too, it will take time writing a code. Now, when AI and all these things are coming, if you use AI, ML techniques in a good way, in a wise way, that will help us. That will reduce the complexity of work. You can do more work at the same time as we were doing 10 years ago. Like that. So if we use AI and ML in a good way, it is going to really change the whole world within the next few years, maybe 10 years or so. But if you are using it in see, if you want to become over smart, then that is not possible. You just write your project report and submit it to me. Within 1 minute, I will tell it is AI generated, cancelled. That is the thing. Because your work you have to do. But you can take the help of grammatical errors. You can take the help of, okay, one sentence, I want to make it more better. How to make that sentence more better? Avoiding plagiarism. That thing you can do, definitely. You don't know anything about plasma astrophysics. Okay, at first, let me see, can I download 20 papers on plasma astrophysics by querying to ChatGPT or Google AI? Definitely you can take that. But if you see 20 papers, then you say, okay, what work has been done? ChatGPT tell me in that particular paper. You will be doomed. That you have to read.
Okay.
That is that story of patience. passion, patience, punctuality.
Yeah.
Yeah, very good question. Yeah, yeah.
Okay, sir. Thank you.
Okay, okay. Thank you. So yes, it is.
Mike, you can go ahead and ask the question.
Hello, sir. Thank you for the wonderful talk tonight. And am I audible? Hello.
Yeah,
Yeah, you are audible, Mayur. Tell me.
Yes.
yes,
I
you're
am
audible.
I am very enthusiastic in quantum mechanics, and I want to make quantum computation as my career often. But I was also enthusiastic in astronomy and astrophysics from the very start because sky fascinates me. And as you were saying, quantum computing is going to help astrophysics in the long run. I was very curious that how would quantum computing contribute into astrophysics and astronomy?
Definitely, as I was telling, almost a similar question. Yes, quantum. See, quantum computing, this AI, ML, this is going to change. As I was discussing, we were 10 years ago, we were thinking of means manually checking 1 lakh spectra of stars and then start our doing research. Yeah, means or you write a code. Now this writing code also will become more easier taking the help of AI and ML. Yeah. Then using quantum computing, definitely if you are interested in quantum physics, definitely it is one of the most important parts, because if you want to know the smaller scale means physics related to astronomical objects, we have to understand quantum physics. Yeah. In the smaller scale, in the atomic level, molecular level, electron level, how matter works, how matter behaves, in case of astrophysical objects also. So again, I will tell you, in quantum physics also, this is going to, quantum computing will change. It's going to revolutionize everything. Because computational aspects is very powerful nowadays. But to think about 1 lakh, don't think about 1 lakh spectra. Think about 1 crore spectra. If you want to study 1 crore spectra of stars, how will we study that? Even if we write codes, it takes time to run the code. And in places where we stay, it is a remote place. Suddenly load shedding happens, or UPS is not working properly. The code suddenly corrupts. The quantum computing thing, maybe if we can ultimately run such huge codes within a minute, within a few seconds. So this is how this technology, hand in hand with pure science, commerce, this is going to revolutionize astronomy. I'm not telling that we are standing in golden age of astronomy. I say we are actually standing. So, but yes, if you want to specifically find out how, what type of way quantum physics is helping in astrophysics, take the help of internet, take the help of ChatGPT in a good way. Search out, find out some papers. Yourself, find out some papers where quantum technology or quantum science is being applied to do some work in astronomy. Try to find out, because these things you need to do yourself. You have to do, otherwise it will be late. You have to do. Yeah, but yes, it will be important. Definitely it will be important. Well, somebody else wants to ask some question?
Rakshit, you can go
Thank
ahead
you,
and ask.
sir.
Yeah, thank you. Yeah.
Good evening, sir.
Good evening. Yeah.
Sir, could you tell us some examinations and colleges for pursuing astronomy or astrophysics after 12th other than IITs, sir?
There are, so it's a good question. See, in after 12, nowadays, there is this new education policy has been implemented. So you cannot directly go to BSc or BTech in astronomy. That is not possible. But you can join BSc with physics or BS in physics, graduation with physics major or physics as main component. But additionally, you can take astrophysics as a specialization. For example, one of the best private universities in India for this astronomy research and astronomy teaching is at present in Bangalore, Christ University. Yeah. Apart from that, there are so many other universities. You yourself search out. Yeah. Like QSAT, Cochin University of Science and Technology in case of Cochin, Ashoka University. After 12th, if you want to take, then there is Pune. There are some private university known as World Peace University. Like that, so many are coming. Every year it is coming up. Apart from IITs, apart from top institutes, these are also coming up. Is there any such institute, if you are from Bengal, is there any such institute in Bengal? You search out. Just put a query in Google. astronomy, how can I pursue astronomy after class 12 in private universities? BITS Pilani, BIT Mesra. These are some of the institutes. So, but apart from that, where are the other places? These are some of the top institutes, very good institutes, where you can take graduation with physics as main component, major, or physics as specialization, but your specialized area you can take in 1 or 2 papers you can take during your coursework. You can take either specialization in astrophysics or project in astrophysics, or in your BSc physics, you will have astrophysics, elective papers. That area is increasing. So some of the colleges I am telling you, some universities, but every year it is increasing. Try to find out.
Sir, like one more question. Sir, is there any way to like take admission in IIST, Indian Institute of Space Science and Technology, other than JEE Advanced?
No, that is the only way. JEE Advanced top score. No, that is the only way.
Thank you, sir.
No. Okay, also I am watching some questions, I guess, in messages also. So suppose, okay, Simarjit Kaur, I want to ask, what you think is the biggest mystery in the astrophysics right now that you think we will solve in next few decades? Maybe so many. Very good question, maybe so many. How we came, what is life? Have you ever asked yourself, what is life? If you try to think, you will get puzzled. You cannot tell me that, okay, life means those types of entities which can reproduce. There are so many animals in our own earth which do not reproduce. Okay, life reacts to stimuli. What about mercury? Mercury thermometer. So when you have fever, we put in our mouth, it also reacts to stimuli. Life moves, locomotion. What about trees? Well, so it's a confusing case. Life takes food or takes energy for metabolism, right? What about fire? What about car fuel? It also, you give fuel to a car engine, it will take it and it will metabolize, it will run. It will also move. So is engine life or fuel life or fire life? So what is life? Think about this simple question. There is no proper definition of life till yet. We have not defined life yet. To understand what is life, we have to understand astronomy very, very deeply. We have to find life in other places outside our Earth. So this is only one example. I am not telling this is the greatest mystery we will solve. What is singularity? Does singularity actually exist? What is dark matter? What is dark energy? Does parallel worlds exist? Does parallel universe exist? How our universe came into being? There are so many problems, so many wonderful evidences has come. Because of that, we have to believe that Big Bang actually happened. But there are so many problems also, which we have to solve. How a star dies, supernova. We have to understand very, very well a big star, massive star. It's not so easy that we tell, oh, a supernova will happen and a big star will die. But the fine tunings related to supernova, what star is born, star formation is a very big mystery. So there are so many, but it's a very good question. Read some books. I will always suggest read some books. You will get fascinated. Each and every object on astronomy you read, you will get hundreds of questions. Okay, how our one project in astronomy wants this is, I didn't understand. Kajan, you were asking, jet streams are found in oceans and atmosphere. Had anything like this been found in space? Yes, definitely. So the astrophysical jets and astrophysical disks, these are the most common phenomena in astronomy. Astrophysical jets and astrophysical disks. Yes, definitely there are jets. There, when collision of two galaxies happen, there will be jets. When there are so huge hot matter coming out from hot accretion disks of black holes or radio galaxies, there will be jets. So there are such things. Okay, what is the, this is a wonderful question again. What is the most unexpected or surprising thing you have personally discovered or mapped? Well, that is a very technical aspect, but in a broad general way, I will tell maybe 1 minute story is for studying my stars, the stars which we study, to understand some of the behavior of those stars and some of the behavior of how the disk revolves around those stars, the properties of those stars, stellar disks. So we were puzzled during my PhD time for around 3.5 years. Me, my supervisor, they were a bit puzzled. Okay, the results on some particular exercise, some particular research we are getting, we are not actually believing that. Okay, previous people who did it, such type of results didn't come. We are finding some odd results. We thought we are wrong, maybe. But gradually, as I was dealing with that, I was gradually becoming convinced that I am not wrong. But what is the proof that I am not wrong? That proof came by studying the history of CCD cameras and how CCD cameras came to astronomy. That is why I am telling my friends, knowledge is power. And ultimately, within 2 days, that problem got solved. Okay, we were confident. We wrote the papers. We submitted the papers to MNRAS, and MNRAS accepted it. Yes, what you people have done is correct. So this is the thing. Okay, Rakshit, you have told, sir, please suggest some books. What I will do is, there is a list of books. I can put that list of books in to this propagation people. So they can send this list of books to you all. In astronomy, starting earning is, when you become an astronomer, you will definitely earn good. Definitely. Is there any other who? Manyata, you want to ask some question?
Sir, I think.
Yes, sir.
Yes. Please ask.
Yes, sir. Good evening, sir.
Good evening. Yes. Yeah.
Sir, like how does the nature of different wavelengths, like in the electromagnetic spectrum, the different rays are differentiated by their wavelengths. So, sir, how does we determine the design of the telescope, like for observing a particular like radio wave or ultraviolet rays, sir?
You have to understand. Yeah, we have to understand the properties of those radiations. Suppose radio wave. If you just make a radio wave telescope in the form of an optical telescope, tube-like structure, then radio wave, you cannot capture radio wave. Radio waves are the largest, having largest wavelengths among all other electromagnetic radiation. Radio waves have the largest wavelength. So studying radio, that means radio waves can come from cool objects also, hot objects also, and it can pass through huge dust chambers. There is dust, interstellar dust, and it can pass through dust without being attenuated, without being destroyed. So basically, the places in the places from where optical light cannot pass through dust, it cannot pass through, but radio waves from those places can pass through us. But to detect those radio waves, you have to make an antenna-like pattern. To detect X-ray type telescopes, you have to make such type of instruments which will give you grazing incidence. Grazing, not direct. Because it's so highly energetic, if it hits a mirror, mirror will be destroyed. So you have to understand the properties of each and every electromagnetic range or the spectrum or the wavelength range. Say what is X-ray, what is gamma ray. So then only you can make the instrument in that way. Gamma ray, if you make a mirror, it will be crashed, means mirror will be destroyed. This is so energetic. Yeah. So that's why understanding the properties of this type of rays, then only you have to understand how to make the telescopes, how to make the instruments which can catch them. Yeah, this is it. So you can read, some books are there, you read teachastronomy.com. Read that.
Okay, sir. Sir, like, can we develop a single observational system, like, which is capable of detecting, like, different imaging's entire electrospectrum?
Yeah, very good question. But as of now, that is not possible. Maybe in future, if that happens, the one telescope which will observe every type of, maybe we'll switch the mode, like we change the speed of a fan or AC. If that happens, then maybe it's a long dream of human beings. Maybe I also sometimes dream like that, but that is a huge dream, maybe. So that is, as of now, means if somebody can make it, definite Nobel Prize. This is the thing. Because the properties of waves are different. So we cannot think, according to our present knowledge of humanity, we cannot think of a mechanism by which we can make such a wonderful instrument, detecting all waveforms or wavelengths. No. But definitely one day people like you definitely will think people are very intelligent human beings. Okay, there is.
So can I ask one question?
Yes, yes.
Thank you so much, sir.
Thank you, thank you. Yeah.
Yes, sir. Please go ahead. Yes, Professor.
Dr. Banerjee, you have given a very nice talk.
Thank you.
And I like to ask that there are many big observatories in India. Are they looking for exoplanets?
Yes, yes. In our observatory, you'll see. So exoplanet science was one of the major tasks till around 5 years ago. But from our observatory, what is happening in Kavalur, especially in Kavalur, the climate is changing. So monsoon is becoming more stretched. So for exoplanets, we need very high precision photometry and all these things. And very high precision, high resolution spectroscopy data. So that we are not being able to do from our Kavalur observatory at present. So people who are studying using Hanley telescope, Hanley or Indian Astronomical Observatory telescopes, or telescopes from PRL. So they also have Mount Abu. They also have their observatory. So they are mainly looking into this. They are doing good work. But from Kavalur point of view, even 7 to 8 years ago, till around 10 years ago, paper publication has come studying exoplanets, where exoplanet data was being studied from our own observatory. But as the climate is changing, that high resolution sky and high resolution spectra, we are losing that. Even high resolution photometric data, that much high resolution, we are not being able to get. And so that is shifting to other places, definitely. But yes, it is done. IIA also does astronomy, exoplanet astronomy. PRL is one of the champions in exoplanet studies. Apart from that, there is IUCA, Aries. They are also involved in these studies.
And my next question is that if I do asteroid detection from my home, do I require a telescope?
As of now, yes, because you need to take pictures, fast photometry or fast pictures every day of the same region of the sky. So now if you do this flickering effect, because since asteroids are fast moving compared to the background stars, so you see the asteroid moving. So if you're taking, this is the same way by which asteroids are discovered actually, apart from spectroscopy and hi-fi classes. The simple way is this, fast photography. The same area of the sky should be clear. Same area of the sky, maybe 100 days you are taking at the same time. And then you try judging the pictures. So there will be some object which is moving faster. It can be a planet also. It can be an asteroid. It can be a comet. It can be an artifact. If you read about this famous story, Tintin story, Ashtarjulka, suddenly some professor is watching a spider sitting on the moon, big spider. Then Tintin came and told, no, this is not a spider sitting on the moon. This is a spider sitting on the top of your telescope lens. And then, then this is not a discovery.
Nice story.
Yeah, so fantastic, so Ashtarjulka.
Okay, thank you.
So that has to come, but so with all things proper, if you are going to some place, maybe not Calcutta, not some place which is hugely rain-fed, but we need at least 20, 40, 100 to 200 pictures of the same patch of the sky, maybe for 200 days. So then if you are doing that flickering effect, if some object is passing, it can be ISS also, it can be Starlink satellite also, but that has to be judged. This is the thing.
Okay, thank you.
Thank you. Yeah.
I think so. We have one last question for you from Mritika. And
Mritika, yeah, Mritika. Tell.
Mritika,
Hello,
are you
sir.
there?
Hello, yeah.
Hello, sir. Can you hear me?
Yes, you can hear. I can hear you.
Sir,
Yeah.
my question is in full moon night, if we see the moon from the roof, sometimes it's big, seem bigger, or sometimes it seems smaller. So can you explain me why this happened?
Yeah. Very nice question and very simple answer. You see, every planet, every moon, every satellite is revolving around the moon. there is a satellite revolving around Earth. We are planet. Planet is revolving around Sun, but these are not in circular orbits. These are eccentric, elliptical orbits. So if if this is a moon, and if it is revolving around me, or if this is moon revolving around a circular orbit, then the distance between Earth and moon will always be same. And you will always look at moon and it will appear of the same size. But if it is not like that, if it is revolving in an elliptical orbit, sometimes if it is moving further away from you, sometimes it is appearing closer to you. So when it is closer to you, then it is appearing bigger. When it is farther away, then it is appearing smaller to you. It's because of the elliptical orbit.
And sir, in those full moon nights, sometimes the moon seems red, and then after sometimes it's become orange, and it become yellow, and after some time it's become fully white.
Yes.
So can you explain this?
This is because of our effects coming from reflection through clouds. This is earthly atmosphere through clouds, how the cloud patterns are, how the reflection is happening from moonlight to us. So this is an atmospheric phenomena of us. This is the thing. So it means bigger and smaller moon. That is because of the elliptical orbit, how far it is from us. But this color changing effect is coming from reflection of moonlight through different layers of clouds. How much is the cloud cover? How much is the atmospheric turbulence, atmospheric cover? So it's atmospheric effect. It's because of reflection and refraction. This is the thing.
Okay, sir.
Thank you. Thank you. Okay, well, this is okay. There is a question, Isha, who has asked, sir, we all know about the phenomena of black hole, but is it really existing white hole phenomena? A white hole, Isha, is basically till now a theoretical concept. So we haven't found a white hole till now, but maybe in future if we find a white hole. So it is still now a hypothetical concept. We cannot say anything about whether what is a white hole, whether it exists or not, till we don't find it. Like that. Okay. What is astrobiology? Astrobiology is the subject through which we study life outside our Earth. So it is definitely going to survive. Shivam, you have asked a good question. Okay, yeah.
Sir, can I ask one more question? Last.
Yes, please ask. Yeah.
Sir, I have a question about the states of matter and the fundamental forces. Sir, I have a question that we know that there are 22 states of matter on which 10 have confirmed. And we also know that the fourth and fifth state of matter are the most common. Solid, liquid, gas, plasma, and Bose and string condensate.
Condensate.
Yes, sir. But
Yes.
But after that state, like fermionic condensate, super solid, why don't we see these states in a higher amount?
Because it is not easy to get that type of temperature, that type of condition in Earth. Even if you go to space, in natural cases, suppose 6,000, 10,000 degrees Celsius, you will see plasma. You will see super condensate, Bose-Einstein condensate material. But those, that 6 state, 7 state, it is not easy to form. It is not easy to form. We need so many specific things to happen at the same time in a very critical way, very specific way, so that that type of 6 stage, 7 stage will form. So also for us, it is in earthly condition, it is almost impossible. In general outside condition, we have to find it out. It is a very huge universe. Since it is very not easy to form, suddenly we will not find it. So this is the overall picture, actually.
And sir, I have one last question. After that, I will not ask that. We know there are 4 fundamental forces: strong force, weak force, magnetic force, and gravity.
Electromagnetic force, yeah, not magnetic, electromagnetic.
Yes, sir.
Okay, yeah.
We see strong force in atoms, electromagnetic force in magnets, and gravity is the most common. But why don't we see weak force?
No, weak force, yeah, very good question. Weak force will act inside atoms, only inside atoms, for the electrons and protons.
Then why, sir? Why only inside the atoms?
Because its range is like this. Suppose if I tell you that, okay, you go and fight with the great Kali, or a sumo wrestler, that is, or if you ask me the same question, Sir, you are bigger than me. Can you fight with a sumo wrestler or a champion of wrestling? That I cannot. Why? Because you can understand, because that is not beyond my cup of tea. Like that. So, but if you ask, okay, sir, can you fight with me? Then I can say, yes, I can fight with you because you're smaller than me. Like that. So, like that, see, these all four forces have their range of action. So weak force, the range at which weak force can act properly is very, very small. And that range is inside atoms. It's not even meters, not even feet, not even inches, not even millimeter. It's in picometers, very, very small distance it will act. But gravity, it is the force, gravitation, which can act at highest distances. So that's why we feel gravity, but we will not feel weak force.
So, sir,
This
can
is
you
the
give an example of a weak force that where it is occurring?
No, example is that only inside atoms, protons and neutrons putting together, they are not coming out from the nucleus. That is the example of weak force.
Okay, sir.
Otherwise not.
Means that weak force helps the quarks to be stable inside the atoms. Am I right?
That we have to think. Quark picture we have to think better, more deeper. Yeah. But in that level, weak force acts. Yes. If you go to quark, if you go to leptons, antiproton, all these things, in that level, weak force works. But how it works, how it interacts with weak quarks, that is again a big question. Research is going on. Yeah.
Okay, sir.
Thank you. Yeah.
Thank you.
Shivang, okay, LinkedIn ID. I don't have LinkedIn ID. I have WhatsApp. So that I can share. I can share my WhatsApp number here. Okay, 9830677657. So this is my WhatsApp number. If anyone wants to contact me, you can. Okay.
I think, sir, most of the questions have been answered.
Yes.
If there are any.
There is one more question. You see, like Rakshit, how to think like a scientist? Very good. First, increase knowledge. Then only you can think like a scientist. Wonderful question. Yeah. See, it's not a course, right? You cannot come and tell, okay, or I cannot, apart from astronomy, I like law. But I cannot go to a court and tell that, okay, there is a criminal, I would like to fight for that person, and I would protect that person. I will not be allowed, right? Because his life is at stake. Or I might like medical science, I might like surgery, but I cannot go to a hospital and say, oh, today, doctor sir, please, you remain away, please give me the knife and I will do the surgery. But why a doctor likes to do surgery, blood and all these things? Why? Who told when he was in class 7, 5, 4, like you people 10, who told that you can become a doctor? And if you become a doctor, you will only deal with patient blood. Who told? Nobody. See, it's about you read and read. Which thing fascinates you the most? If cricket fascinates you the most, then play cricket with dedication. 100% dedication. Think about this Vaibhav Suryavanshi. You know Vaibhav Suryavanshi, how much dedicatedly he has practiced. Read Sachin Tendulkar. Great. So if I just think that today, oh my God, Vaibhav Suryavanshi is earning very good cricket he is playing. Tomorrow I want to play like Gourav Banerjee. I cannot. So for that you have to understand that this is a long process, and you have to first think which area fascinates you the most. For that there is only one way: reading, knowledge. If music fascinates you the most, try to go to music. So like that. If commerce fascinates you the most, try to become a businessman or go to commerce line. If banking fascinates you the most, if you go to bank with your father and mother, say, oh my God, I like the people who are working in bank, then go to banking. So this is the thing. See, it's not a way that I will tell, okay, if you eat a Califos 12x tablets, then you will become a scientist. Your intelligence will increase. Rubbish. There is no medicine which can increase your intelligence. There is no way by which you can increase your intelligence apart from reading, apart from knowledge increasing, apart from hard work. Otherwise, no. Okay, thank you. Yeah. Minu Kambos, I did MSc in instrumentation. What astronomy scope I can be? A very good question, Minu. You can go to, if you have, when you have done MSc in instrumentation, you can take a course known as Integrated MTech PhD in Astronomical Instrumentation. This is given by ARIES and IIA in India. So you will get both MTech and PhD. You will become an astronomical instrument expert, scientist in astronomical instrumentation. Go to IIA website, go to opportunities, PhD and all these things. You will see Integrated MTech PhD in Astronomical Instrumentation, also in ARIES, it is given. And you have to crack an exam, either UGC NET or JEST or GATE, and then go for interview. If you're cracking the interview, you will get a chance with full scholarship. This is the thing. What is proton-proton chain, nuclear fission? Okay, you read about it. Nuclear fission, see, there are ways by which energy can be produced. So when we think about how energy is produced inside a star, there are two ways, basically. Inside a star, two ways are there. One is two protons, basically protons joining together or fusing together to form a heavier element, helium. One proton means hydrogen. So two protons or few protons joining together to form helium, and during this process, some energy comes out. So that is the energy which is throwing out, which is produced by stars. So this is how it happens. So proton-proton chain reaction is a process by which low mass stars produce energy, like our sun-like stars, where protons will fuse or join together to produce energy. But you read about it. Just go to this teachastronomy.com and read about energy production in stars. Very nicely, easily written. Read about it. Okay. Thank you everyone.
Thanks, sir. That's all for the questions today. This has been an extremely great session. I think you have answered everybody's question and people have got all their answers. I really liked the session, sir. It was absolutely fantastic. Thank you so much for coming in here. We are extremely grateful again for you with us to join us with these sessions. We are extremely grateful, sir. I think we should do one last thing. We should ask the people to open their cameras and we'll take a quick picture with everybody, just as a form of memory. And we'll end the session right there.